Today we're going to look at section 3.4. It's a pretty direct continuation of what we did last time where we learned about the slope. So go ahead and write down the title, 3.4 Equations of Lines. We're going to look at two different equations that you can write for any linear equation. And both of these I know you saw last year. So a real quick reminder, slope-intercept form we've brought up a couple times. We started talking about slope, and you'll find it on your reference sheet. Looks like y equals mx plus b. Again, y equals mx plus b. Whenever you're dealing with slope-intercept form, the m, like we used last time, represents the slope, and the b represents the y-intercept. Okay. So m's the slope, it tells you how to move. The b is the y-intercept, so that tells you the point that you're going to plot first that's on the y-axis. So remember, when we look at our axes, x is the one that runs horizontally, y is the one that runs vertically, so the y-intercept will be a point directly on the y-axis wherever b tells us to place it. So example 1 illustrates how we're first going to work with this. So write the equation of a line with a slope of 2/3 and a y-intercept of -4. Then graph the line. So when you read a problem like this, you're going to need to break down what exactly we're given and then base what you need to do off of that. We're given everything we need to know in this one. Specifically, we're told the slope is 2/3. So since 2/3 is the slope, that's going to be what we use in the m spot. And then the y-intercept is -4. So that's what will go in the b spot. So we're going to go up to this and basically just fill it in where it's going to be y equals. Use the slope for m, so put the 2/3 x, and then instead of plus b, we could write plus -4, but often we just change that to a -4. And that's it as far as writing the equation. If you know the slope and you know the y-intercept, you just get to plug them in where they go. And then to graph it, sketch a coordinate plane. I will provide you graph paper when you work on the assignment, but for your note, just make a sketch. The grid doesn't need to be there. Just sketch your x and y axes, label a few of the numbers. Like I showed up here, the first thing you're going to do is start with whatever the y-intercept is. So in our case, -4. So y-axis runs vertically. We'll go down here to -4. There's the first point. And then to move from there, we'll do whatever the slope tells us to do. Remember last time we kind of remembered that slope could be interpreted as rise over run. Since it's a positive slope, it is going to increase from left to right. So we're going to go up 2 over 3. So start at -4 where the y-intercept is, go up 2 over 3. There's a new point. And it's a good idea to usually do that at least twice. So again, up 2 over 3. If you check your points, they look like they'll make a line. So to finish it, as best you can, connect those 3 points with your line. Okay. So the first set of problems you have in the assignment will be a lot like that. They'll tell you the slope, they'll tell you the y-intercept. That's it. Other ways that you might see the y-intercept, they may use the word like this one. They could have told us that b was equal to -4 and made it even more obvious. They could have also given us an ordered pair. So if they had have told us we had the point 0, -4, that would still be the y-intercept. So if they give you the ordered pair, but it's 0, something, that's still your b. So that is slope-intercept form. So remember, y equals mx plus b. And really watch the directions. They'll tell you which way to write it. The other form that you've also worked with some is called Pointslope Form. And it looks like this. Y minus y sub 1 equals m times x minus x sub 1. In this form, m is still the slope, so we treat that like we did before. But instead of using the y-intercept, we're using some point x1, comma, y1. And that can be any point that's on the line. It doesn't specifically have to be the y-intercept, although it could be. So an example using this, pretty similar direction, but we're supposed to write an equation this time in point slope form. a line with a slope of -3/5 that contains -10/8, and then we'll graph the line. So looking at it, again, pay attention to the info that we're given. So we're told the slope is -3/5. So since it's a slope, that's our m. And then it has the point -10/8, and that's the only point we're given, so there's no choice. There will be some problems, like our next set will have 2 points, and then you can choose. But in this case, that would have to be the x1. 8 would have to be the y1. So then we look up here. We copy down the y, minus y1, so that would be our 8, equals, m is -3/5, so that goes there, parenthesis, x, and then we'd subtract -10, but we should know we're not going to write it that way. So instead of minus a -10, we'll change it to a +10. So whatever signs you see in your point, like -10, +8, you'll see the opposite when you look at your equation, a -8 and a +10. And then if you're supposed to leave it in point slope form, leave it like this. Do not distribute, do not move that over. This is what it's supposed to look like. And then to graph it, again, sketch a coordinate plane. Instead of starting with the y-intercept, we'll just start with the point that we were given. So this time we had -10, +8. So I need to extend mine a little bit. So that would be -8, -9, -10. So -10, +8. And then, like the previous problem, follow what the slope says. Since our slope is negative, from left to right, we're going to be going down. So we go down by 3 over by 5. Down by 3 over by 5. And as best we can again, connect that with a line. So that's what point slope form looks like. And again, when you're doing the problems, make sure you're aware of what the directions are telling you each time. Some of them will be asking for slope intercept, so use y equals mx plus b. Some of them will want point slope form, so use this one. Example 3, we're going to look at a slightly more difficult problem. We're going to write the equation on the line with the given points, and we're going to start with 4, 9, and 2, 0. And I'm going to be specific. I want this in SlopeIntercept form. So in this one, we don't really have a lot of information. We're just given the points. We're not given any information about the slope, but we learned last time how to do that. So our first step on these will be to calculate the slope. So like we did last time, x1, y1, x2, y2. And then our slope formula is y2 minus y1 over x2 minus x1, which would give me -9 over -2. And then since they're both negatives, we can go ahead and just change that to +9/2. And then our second step, we're going to plug in this point slope form. So write down y minus y1 equals m times x minus x1. Now we can choose which of these 2 points we use, and a lot of times I'll look for whichever one's easier. So to me, 2, 0, because that's smaller than 4, 9, looks like it'll be easier. So I'm going to go with that. So it could be y minus 0, since that's the y coordinate, equals m we calculated, which is 9/2, and then x, since I use 0 for y, I'll use 2 for x. And then the third step would be to change it into slope-intercept form, which means we want the y by itself. So this is a two-step problem. The left side you'll usually just copy down. You're going to have this on this side, so you could distribute it and get 9/2 x minus 9. And then whatever's over here you'll get rid of. This one's kind of special since it's a 0, which kind of gets rid of itself. So our answer would be y equals 9/2 x minus 9. Practice another one. So this one we're going to look at -3, -7, and -1, 3. So I'm going to go over here with that work. -3, -7, -1, 3. So three-step process again. To begin with, find the slope. So we would do 3 minus -7 over -1 minus -3. So change those to pluses. We'd get 10 on top, and our denominator would become 2, which we could reduce down to 5. Step 2, plug it into point-slope form. So y minus y1 equals m times x minus x1. And again, it does not matter which of these 2 points over here we choose. I'm going to use this one because it looks easier. So that would be y minus 3. That equals, we found that our slope was 5 times x minus a -1. So we'll change that to a +1. And then third step, we're going to get the y by itself. So I would write down y minus 3. I would distribute the 5 and get 5x plus 5. And then this time there's one more thing to do. We still want the y by itself, so to get rid of the -3 we would add 3. And it's a like term with the 5, so we'll combine them. Cancel. So final answer, y equals 5x plus 8. So that's how those go. If you have 2 points and you want it to be in slope-intercept form, it's a 3-step process. Find the slope, write it in point-slope form, and then isolate the y, and then your final answer will look like that, and that is slope-intercept form. There are 2 special cases of equations that don't quite follow the same rules as what we looked at, and they are if the lines are horizontal or vertical. If a line is horizontal, y equals b is the equation that we're going to use, where b is the y-intercept. So horizontal lines will just be y equals some number, where b is the y-intercept. If it's a vertical line, instead of y, it's going to be x equals a, where a is the y, or the x-intercept, sorry. So an example, let's say I've got -2, 5 and -2, 7. So my first step would be to find the slope. So I would take 7 minus 5 over -2 minus -2, which gives me 2 over 0. And if you remember from last time, whenever we're dividing by 0, we'll say the slope is undefined. When the slope is undefined, it's a vertical line. So our equation is x equals a. So it's x equals, if you look at both these points, they both had -2 as the x-coordinate, so that's what we use there. So that would be the equation of that line. X equals -2. If we had have gotten 0 for the slope, then it would have been horizontal, but vertical, remember, is undefined. Okay, last example. Example 4, I want to write an equation in slope-intercept form for a line perpendicular to the line y equals 1/5 x plus 2 through the point 2, 0. Write an equation in slope-intercept form for a line perpendicular to the line y equals 1/5 x plus 2 through 2, 0. So some keywords there. We want our answer in slope-intercept form. Our equation is perpendicular to this one. Our equation has the point 2, 0. And if we look at this equation, the slope would be 1/5. So that's the key information in the problem. The answer in slope-intercept form, perpendicular to the line with a slope of 1/5, and it goes through 2, 0. What we learned last time was if a line has a slope of 1/5, if we want a line that's perpendicular to it, we need the negative reciprocal. So we'd make it negative, and instead of 1/5, it would become 5/1. So we could just say -5. And now that's our step 1. So our step 2, just like we did on some previous examples, go with y minus y1 equals m times x minus x1. This is our only point, so that's the one we'll plug in. It would be y minus 0 equals -5, so that's a slope, times x minus 2. Do the math. We'll get, for step 3, y equals, since the 0 doesn't matter, distribute -5x plus 10. And that would be the answer. That would be the equation that's perpendicular to this line, since their slopes are negative reciprocals, and our line passed through the point 2, 0. So when you have those, pay attention to the keywords perpendicular, negative reciprocals. If you see any that are parallel, remember that means the slopes are the same. And that's it for notes. Your assignment that we do next time, 1 through 12 all, 13 through 41 odds.